Hello everyone. So today we are going to solve problem number 2707, extra characters in a string on LeetCode. So let's first read the problem statement. You are given a zero indexed string S and a dictionary of words dictionary. You have to break S into one or more non-overlapping substrings such that each substring is present in dictionary. There may be some extra characters in S which are not present in any of the substrings. Return the minimum number of extra characters left over if you break up S optimally. So let's look at an example to understand it more clearly. So in example number 1, we have string S as leet S code, and we have a dictionary which have words leet, code and leet code. So we can only break S without overlapping. So here non-overlapping means we can only break from here, or we can say from break from anywhere we can break, but the characters cannot overlap. Suppose I have breaked here leet and it's S code, so we will have leet and S code. So these cannot overlap with one another. So when breaking optimally, we can break from here and here. So only this one extra character is left, and we have to return the size of the extra character because leet and code are present in our dictionary. In example 2, we see if we break, let's say, then hello, then world. So hello is present in our dictionary, and also world is present in our dictionary, but say is not present. So we can say the length is 3 of extra characters. Let's take one more example. Suppose it was here, say hello a world. So we would have break the string S as say one substring, hello as one substring, a as one substring, and world as another substring. So hello and world are already present here, but these three characters and one character, so four characters are not present. So if in this example 4 would be the answer for this. So how can we solve it? So first look at the constraints. So when you look at the constraint, we see that the length of the string s is very low, and also the size of the dictionary is also very low. So one thing that comes straight up in our mind is dp. So whenever see the constraints are very low, we generally think of dynamic programming. And also, as we can see, here we need to try out all possibilities because we can never be sure by cutting at which place we are getting the answer. So we will try out all the possibilities. That means we will try to break at here, at here, at here, at here, at here, at here, and at every place. So let's take the first example, leet as code. Leet as code. So in dynamic programming, what we usually do is we suppose that our function will give the result for the particular subset of the problem. So suppose if I am breaking over here, then I can assume that my function will correctly give the result for this part. for this remaining string s. And if I'm breaking it here, then I can assume same for this part. So how can we solve this? So for every index I that we are at present, we will try to break it each index. So if we're at I, we will first take L, then we will take LE, then we will take LEE, then we will take LEET, then we will take LEETS, then we'll take LEETS C, then LEETS CO, then LEETS COD, then LEETS CODE. And for the remaining part, that is for each test code, we'll assume that our function will give the answer for this, and here for this, for here ts for this. So we can assume that our function will correctly give us the result for this. So what we need to do for the this part? So we can simply check if this part is present in our dictionary, then there will be no extra characters. And if this part is not present in our dictionary, then we can say the length of this string will be the number of extra characters present in our substring this plus the answer result given by this function. So when we reach here, we will see that leet is present in our dictionary, and we would have called as code our function. So what we'll do, this will also run similarly. So what it will do is, it will first break with s and try to get the answer for code, then sc, then try to get the answer for ode, sco, then try to get the answer for de, then scod, and try to get the answer for de, then and no characters remaining, so it will run to the base case. So when we see here that when this is our case, this will give us answer as 0. Why? Because this will also try out every possibilities, and at the end, what will this do? This will try C, CO, COD, then COD, and this will find that COD is present in dictionary, and it will return 0. So we'll get 0 here, and this one will extra character. So in this way, we are getting 1 at the minimum answer. So how will our function work? Our function will be nothing but it will require the given string as, we can say, a map or set of characters st. This will be our dictionary basically, where we will check that if this particular string is present in our substring or not. Then we will have a index variable, and when index will become greater or equal to s dot size, that means they are 0 characters. So if they are 0 characters, how many extra characters will be there? Definitely we can say there will be 0 extra characters in this case. So we'll return 0 here, and then we will suppose take some string current, and we'll initialize it with empty. Then we will try out all possible substrings starting from index. So we'll start from index, and this will go less than size of s, and what we'll do at each step we will try to add current dot, you can say, pushback, and at each step we will add the character at index. So suppose if we had lead test code, so first we this will be part of our current, then le will become the current, then lee will become current, and so on. And at each point what we can do is we can simply check. We can take a variable, say it extras, and we'll initialize it with 0, and we'll check if this current is present in or not. If current in st, so if current not in st, so if current is not present in st, what we'll do, our extras will increase. So extra plus equal the size of this current, and then also what we'll do extra, so extra will also have the result. So extra plus equal the result, if we say util sst and I plus 1, so we'll get the result of the remaining substrings, this, then next time this, the smaller ones, and finally we'll compare to minimum total minimum, which will compare at each step, and finally we will return total minimum only. So let's see the code, and there it will become more clear. So first what we require is we require a map, or we can say a set. So first we'll take a set of string, we call it st, then we will traverse the dictionary for auto x in dictionary, then we'll insert it st dot insert x. Now we have all the words of dictionary in our set. Then we'll return whatever the answer will be returned by our function, utility function st, and we'll start from index 0. And we'll make a utility function. It will have string s. We'll pass it by reference, so as to take less time. Then we will have set of strings. We'll also pass it by reference. Then we'll have our index. Now we'll write our base case. If index becomes greater or equal to size of strings, we return 0, as no extra characters are possible here. Then we will take string current, which will be empty initially. Then we will loop from index till the last element. We will add the current, and what we'll do, then we need to check if this current, so we'll initialize int extra to 0, and if st dot find c current equal st dot end. This means that this current is not present in our dictionary. So if it is not present in our dictionary, it will be an extra character. So we will make extra equals size of current. This whole current will be the extra character. Then we will simply add the result of remaining characters or remaining substrings. So we call utility function as st from I plus 1 because till I we have already processed and we need to process only I plus 1. Then we'll need a int min extra variable. It will be initially s dot size. Then we'll update min extra at each step. It will be minimum of min extra and we can say current extra or extra. And finally we have to return min extra. Let's see if it is running. Okay, there's a typo here. It will be st. So sample test here are passing. But we see that this is at each step we are going n minus 1 times. So this will increase exponentially. So we need to memorize it using dp. So we can see that only one parameter is changing here, that is index. So we only require a 1d dp. So we'll simply make a vector of dp. At each call, we need to resize it. Dot resize and size will be s dot size and value initial value will be minus 1 because no string can have minus 1 as extra character. And at here we'll simply check if dp at index is not equals minus 1. This means it was calculated previously. Then we need to return dp at index and dp at index is minimum extra. So now if we run it and let's try to submit it. So you see it's getting submitted, but we can also optimize it by using tabulation. So this approach is memoization. Let's see in this video how to do tabulation. So in every problem we have to start from memoization only because then it is easy to think. You cannot directly think tabulation in your mind. First you have to think about memoization because it's simple recursion. And let's try to do a tabulation here. For tabulation what we need? So in this memoization we observe that we are starting from index 0 here and we'll go till index in size dot s dot size minus 1. So we see that the first value we are calculating is for the s dot size minus 1. So in tabulation we'll start from there only. So we'll say int index equals s dot size minus 1 and I will be greater than equal to 0 minus minus I. Next what we'll do, we'll simply copy this whole from here and paste it here. Let's shift the tabs. Now we are having a current string, minimum extra variable, for loop which are starting from index and going till last, adding the current extra, start find extra. Okay. Now here where we are calling the function, utility function, it will be simply dp of I plus 1. Then where we are returning dp at index, this will be simply we need to store, we do not need to return here. And finally we are returning util of this will be dp of 0. We also need to observe one thing that our index is starting from s dot size minus 1 and here we are trying to access I plus 1, dp at I plus 1. So this will cause an error when value of I is index dot size minus 1 because adding plus 1 will cause an error. So what we can do is we will simply increase the size of dp, so it will not give us error, and also this initial value will not be -1, it will be 0. Now let's try to run it. So as we can see, it's getting accepted. Let's try to submit it, and we see that our code got accepted. So today we have seen that memorization as well as tabulation solutions. I hope you understand this solution, and if you understand it, please do mention it in the comments. So thank you, and we'll see you in the next video.